Okay, today we're doing solving systems of equations using Cramer's rule. So we're going to find something called the determinant of a matrix, and we use that information to solve linear systems, either 2-variable or 3-variable equations. I couldn't find a good video for this online, so I'm just going to go through the examples. The explanation of how we do this, the formulas is on here, and I'm going to show some where we're using a graphing calculator and some where we're not. So, if you'll look at number 1, evaluate the determinant. So we have a matrix inside these bars that look like absolute value bars, and that indicates to me that I'm finding a determinant. So your terms are A, B, C, D inside your matrix, and you do A times D minus B times C. So we're multiplying the diagonals and then subtracting one diagonal from the other. The order does matter. So 6 times 0 minus 4 times negative 1 equals 0, and negative 4 and minus a negative 4 is going to give me positive 4. All right, so the next one is a 3x3 matrix. The rule that we use for this is called the diagonal rule, and it is quite lengthy. If you do want to see how to do that on paper, it is in the notes on Google Classroom, but I'm going to show you how to do it using a graphing calculator, because once we get into a 3x3 matrix, this gets a little intense. So I've already put mine into matrix form to save myself some time. So here's my matrix: 3, negative 2, negative 1, 2, negative 1, 0, 1, 2, negative 3. That's a 3x3 matrix. So I'm going to go to matrix and math. And then there's a number 1 on mine is DTE, that's for determinant. So hopefully you have that. You can find determinant. You should if you have matrix capability. And then I'm going to choose my matrix, which was H, and it's going to give me the answer, negative 8. Now I tried this earlier and I had missed one of my negatives and my number was completely different. So I always want to recommend to you guys that you double check your numbers in your matrix. Maybe do it one time and then go through and look back at it again. Do I have those numbers right? Because it does make a big difference, even just a tiny little thing like that. The next thing we're going to look at is using determinants to find the area of a triangle. So we're given a triangle, we're given 3 vertices of the triangle, and so we label those as A, B, C, D, E, F. And the formula for that is that we find 1/2 of the determinant of this area of a triangle matrix. So I put in each coordinate of the vertices, and then I put the number 1 as my entire third column. And then we're going to find the determinant, and then we're going to cut it in half. So again, for the sake of time, I've already put this matrix in. So I'm going to go to matrix, math, determinant. This matrix was I. It gives me 17. And then I need half that. So the area of the triangle is 8.5. All right, so now we're going to look at Cramer's rule, which uses determinants to solve systems. So we're going to view our matrix as being AX plus BY equals M, and FX plus GY equals N. The first matrix that we make is called the coefficient matrix. So that's just your X and Y coefficients. So that would be A, B, F, G, which in this case is 5, 4, 3, and negative 2. That minus sign is important, so don't forget it. Then we're going to make matrix equations for our X solution and our Y solution. So the first one we have the X matrix. So the column that had the X's in it now has your two solutions, m and n, and your y column stays the same. So we have 28 and 8, and then 4 and -2. We're going to do the same thing to make the y matrix, except now the x's stay the same. So I have a and f, and then my solutions m and n go here. So that's going to be 5, 3, 28, and 8. So we're going to find the determinant for each one of these. So I'm going to come up here and do this one. So that would be 5 times -2 minus 4 times 3. So -10 minus 12. So -22 is the determinant of my coefficient matrix. Now I'm going to find the determinants of my x matrix and my y matrix. So 28 times -2 minus 8 times 4 is -56 minus 32, so -88. And then we're going to do the next one. 5 times 8 minus 28 times 3 is 40 minus 84, so -44. Now we're going to take the totals from the x matrix and the total for the y matrix and divide them each by our coefficient matrix determinant up here. So I have -88 divided by -22 and -44 divided by -22, which is going to give me a +4 and a +2, and that is the solution to this system. So that was kind of using the mathematical method, doing it all on paper, finding those diagonals. I'm going to show you how to do the 3x3 matrix using the graphing calculator. Again, I've already put my matrices in just to save time, but you set them up pretty much the same way. So you're going to have your coefficient 1, which is 2, 1, -1, -1, 2, 1, 1, 1, and 2. So those are your coefficients for x, y, and z. Pay attention to those negative signs. Then you're going to have your x matrix, where your solutions are in the x column. And then 1, 2, 1, -1, 1, 2 stays the same. Your y matrix, 2, -1, 1, and now the solutions are in the y column. And then your z matrix, where the solutions are going to be in the z column. So I find it helpful to write my matrices out even if I'm going to put them in the graphing calculator. So I'm going to check. Check number 4. So I have 2, 1, -1, -1, 2, 1, 1, 1, 2. All right, that looks good. So I'm going to go ahead and do the determinant for my coefficient matrix. So 1, that was this matrix. So I got 12. And then I'm going to do the determinant of my X matrix. I'm going to check it. Okay, that looks good. So we're going to do the determinant of matrix E. Got 6. Now I'm going to do my next one. Checking my numbers real quick. That looks good. So matrix, determinant, matrix F, -12. And last one we're going to do is the Z matrix. So I'm going to check my numbers again. This one was, I think, G. All right, that looks good. So matrix, math, determinant, matrix, G. I got 24. So now I just divide each of these by the coefficient matrix. I'm feeling pretty good about this because these all seem to be kind of common factors here. So 1/2, -1, 2 is the solution for this matrix. And that is how we use Cramer's rule to solve systems.